All right, let's go ahead and get started on. So this is going to be IUPAC practice number 1. So I'm going to go through every single problem. So please pay attention and let me know if you have any questions. So we're going to get started with number 1. So I'm going to draw every single structure out. So it's going to take me a little bit so it looks exactly the way, or at least as close as I can get it to the way you have it in your worksheet. So this one has several carbons in a chain, specifically 5. And here are the hydrogens. And the hydrogens, like if you're like, why are you putting random hydrogens? So the easiest way is to know how many hydrogens you need is that every single carbon wants 4 bonds. Because carbons have 4 valence electrons, so they need 4 more electrons. That's why they will always form 4 more bonds. So if a carbon has any less than 4 bonds, it automatically gets a hydrogen to fill that missing space, so to speak. So this one you have to name the actual structure, and this one's pretty easy. First, you look to see what is along this continuous chain of carbons, so carbons that are all attached to each other. And that's easy in this case. There's really only one way to go, and that's just these guys right here. There's 5 of them. They're all attached. And for anything that has 5 carbons, you put down pent. Pent means 5. Now, then you figure out if there is any double or triple bonds, and I don't see any. So if it's only single bonds, the ending is automatically ane, pentane. And then are there any additions or substituents, like anything other than hydrogens, hanging off those main parent chain carbons? And there isn't. So that's it. You're done. That's number 1. It's a pentane. There's a simpler pentane. So let's do number 2. So number 2, we have, let's see here, carbon to a carbon to a carbon to a carbon, 1, 2, 3, 4, and then 1 carbon right over here. And then obviously the accompanying hydrogens. See how this carbon right here only needs 1 hydrogen? Because it already has 3 bonds, so it just needs 1 more. As I mentioned, the previous lessons really built into this, like the bonding lesson. All right, here we go. So let's go ahead and name this one. So this one looks like it's got 5 carbons as well, but this is not a pent. The reason being is all 5 carbons are not connected to each other. You can find 2 continuous chains. This one and these guys, they're all in a continuous chain, but not all 5 together. So you've got to pick one or the other, and I'll give you a hint. It doesn't matter which one you pick. They're both going to work. So you have to pick one of the 2 continuous chains because you can't connect all 5 together. So I'm going to pick this one as my main parent chain, which means there's only 4 carbons in a parent chain. And 4 gets the name bute, not but, bute. And again, I don't see any double or triple bonds, so the ending is ane. Now, I do have something hanging off the parent chain, and this guy right here, he's extra. He's a substituent. It would have been a hydrogen there if he wasn't there, but it's not. Instead of a hydrogen, you have got this group hanging off. And that group has 1 carbon. As you can see, 1 carbon. And if it's a substituent group, so it's an addition to the main chain, it only has 1 carbon, we call it a methyl group. Meth, because there's 1 carbon, and il, because it's a substituent. So this becomes methyl. Methylbutane. Now we're not quite done here because you need to tell me exactly where that carbon is attached to, because I can attach it to either this carbon, but I can also attach it to right over there here. So which carbon is it on? So you have to tell me which carbon it's on. So we've got to number this, and you can either number this from this side, 1, 2, 3, 4, or you can number it from the other side, like this, 1, 2, 3, 4. And in the lesson, I told you which side is correct. So I'm not going to spend a lot of time here, but the side closest to all the substituents and double and triple bonds, blah, blah, is the side you want to number it to. So that's the correct way. You want to number it closest to the substituents, so you number from left to right in this particular case. So it's hanging off the second carbon right here. So it's going to be 2-methyl-butane. The 2 designates that the methyl is on the second carbon. All right, number 3. So number 3, we have, let's see here, let's draw this out. Carbon, 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 so 1, 2, 3, so there's 6 here. And then I have like this. All right, so let's do all the hydrogens. And yeah, the hydrogens are annoying, believe me. But if I can do it, you can do it as well. So I'm going to require you guys to get me the hydrogens. Every time you draw structures, you're going to have to draw hydrogens as well. You may not like it, but it's just the way it is. Okay, all right, sweet, sweet, sweet. So here again, you have to identify the longest continuous chain. And the longest continuous chain here, so this could be it, or this could be it. Oh, I was gonna do that with a different color. Click. That could be it. It could also technically be this right here. But the one in the green is definitely not very long. It only has 5 in there, so that one's off. So the one in the yellow has 1, 2, 3, 4, 5, 6. The one in the orange has 1, 2, 3, 4, 5, 6. So it's both 6. Pick your poison in this particular case. It doesn't matter which one you pick. I'm going to pick the one in the yellow. So that's going to be my main parent chain. They're both 6. It's not going to make a difference which one you pick. So in this case, my main chain is 6, and 6 is hex. And no double or triple bonds, so it gets the ane ending. And then I have this substituent hanging off one of the carbons in the parent chain. So again, I've got to number this. And I'm going to number this on the side closest, so it's going to be left to right. It's not always left to right, but in this case, it is. So 1, 2, 3. Oh, those are small. Let's see if I can do better. So that's 1, 2, 3, 4, 5, 6. So it's hanging off the third carbon. And look how many carbons are there in the particular, the substituent. There's 1 and there's 2. 2 carbons, right? So 2 carbons is F. Because it's a substituent, it gets the YL ending. So it's ethyl. And it's hanging off third carbon. 3-ethylhexane. So that is number 3. Number 4. Number 4, we have a carbon triple bonded to a carbon, single bonded to a carbon, and then we just do all the hydrogen fun stuff. There. Okay, this one should be simple, and it is. There's only one continuous chain, so just these guys right here, so that's pretty simple. And there happens to be 3 carbons, so that happens to be prop. Now there is a triple bond right over here. So the ending that you use is ine, not ane, that's for single bonds, ene for double bonds, ine for triple bonds. So the ending is going to be ine. Now notice how I left a space here. Because you have to tell me where that triple bond is. Now, for that, you have to number these carbons. 1, 2, 3. There you go. So what carbon does the triple bond start on? Well, it starts on the carbon number 1. So this is prop 1-ine. Now, much like in mathematics where you don't have to write 1 in front of anything, it's always there, like, you know, or 1 as a power, like you don't have to write 2 to the first power, 5 to the first power. It is what it is. So in chemistry, it's like the identity property. In chemistry, the same thing applies. If it starts on the first carbon, you actually don't have to write 1. So in this case, propyne is a perfectly fine way to name this as well. You don't have to write the 1. If you don't write the 1, it's assumed that it's on 1. If it's not on 1, then you write the number. But you can, if for consistency's sake, if you just want to make sure you always have a number there, you can, in this particular case, write prop 1-ine, and that's fine as well. And there are no other substituents hanging off the main chain, so that's the end of that problem. Let's move on to 5. For 5, we have carbon, 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 double bonded to carbon, carbon, carbon. All right. And and then we have and then like this, and yes, that is annoying. Believe me, I'm not a fan of doing this, but this is the correct way to do this, so yeah. All right, so here you have to first identify the parent chain. So here's one possibility. Here's another possibility. Here's a third possibility. And as you can tell, anything but the yellow results in only 4 carbons. The one in the yellow results in 5 carbons, so that's the one we're going to go with. So 5 carbons tells us it's a pent. Now, is there a double or a triple bond? Yes, there is, right here, a double bond. So we know the ending is going to be a pentene, ENE, ENE for double bonds. Now again, I'm going to leave a space here because for double and triple bonds, I have to identify the location, unless it's on the first one. Then you don't have to. But I'll give you a bit of a hint. It's not on the first one. It's somewhere in the middle. So to know which one it's on, I have to number. And I can number from left to right, 1, 2, 3, 4, 5. But in this case, this is going to give both my double bond and my attachment a higher number than I really want. Actually, my attachment is going to get the 3rd carbon regardless, but my double bond in this case is starting on the 3rd carbon. But if I number from right to left, my double bond actually starts on the 2nd carbon. And starting on the 2nd is better than starting on the 3rd. So that's the way we number. So where is the double bond starting on? The 2nd carbon. So it's a pent-2-ene. Great. Now I have to worry about him. Now that's a single carbon attachment. So it's going to be a methyl. That's what single carbon attachments are. Meth because it's 1, il because it's an attachment. And what carbon is it attaching on? Well, right here, the 3rd one. So it's a 3-methyl pent-2-ene. And that's number 5. Numero 6. Okay, all right. So this one has 1, 2, 3, 4, 5. Okay, is that 1, 2, 3, 4, 5, 6? Okay, 7 going this way. I'm just gonna go write them straight. 2, 3, 4, 5, 6, 7, and then 1 on here, 1 here. Okay, all right, cool. And then the rest hydrogens. Ah, yes, the wonderful hydrogens. That's probably going to take up most of this video's time, is me writing in hydrogens. And I could cheat and just tell you, you know what, I'm just not going to write them because I'm the teacher, but I want to be fair. I'm going to force you to write them. I got to do it myself as well. And you're like, well, why don't we have to write them? Because I need to know that you understand the whole thing with 4 carbons bonding. And I know, but I don't, you know. So anyways, we got to do it. All right, we're going to be proper. This one's pretty easy to figure out what the longest chain is. It's this big one in the middle. I believe there's 7 carbons. 1, 2, 3, 4, 5, 6, 7. And 7 happens to be, if I'm not mistaken, hept. Comes right after hex. And how many, are there any double or triple bonds? No, so the ending is a generic A and E. So this is a heptane. I don't have to leave room or anything because single bonds are everywhere, so I don't have to identify where the single bonds are. So heptane. And then I have not one, but two attachments. They're both single carbon attachments. And yeah, so I've got to tell you where these carbons attach. So I want a number. And you're not going to be numbering from right to left in this case. Left to right is closer to both attachments, so that's how you would number. So you number the parent chain. All right, the first one is on a second carbon, and the second one is on the third carbon. So the way you write this is, the long way of writing this would be 2. So there's a methyl on the second one, so it's 2-methyl. And then there is a methyl on the third one, 3-methyl. Heptane. You're done. So 2-methyl, 3-methyl heptane. Now, there is a shorter way of doing it, and you can do this one. This one's perfectly fine. But if you want to take a bit of a shortcut, what you do instead, you're telling me there's 2 methyl groups. So you can say dimethyl. Di means 2. Dimethyl. And then say 2, 3. So the 2, 3 tells me where the 2 methyls are. So dimethyl tells me there's 2 methyl groups, and one is a 2, one is a 3. So you can still do the whole 2-methyl, 3-methyl heptane, or you can do 2,3 dimethyl heptane. So just one is a little easier to write, but it's up to you. If you want to do 2-methyl, 3-methyl heptane, perfectly fine by me. So that is number 6. Let's go ahead and do numbers 7 through 10. We're almost done here. So number 7 is coming, I'm sorry, 7 through 14, right. Ah, this one has more, okay, good. Yeah, 7 is next. So here we have, let's see here, carbon to carbon to carbon to carbon. I'm not sure why I'm not doing them in a straight line. To carbon, that's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Triple bond to carbon, and then off this carbon there is this going on. Okay, all right, good. This is going to be a fun one. Hydrogens. All right, here we go. Boom, 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 boom. All those are terrible hydrogens, but it's the effort that counts, right? Oof, that's even worse. I'm sure there's an H in there. Yeah, all right. So okay, all right. Goodness gracious. So let's go ahead and solve this one. So first of all, parent chain. So I can either go this way. That's 1, 2, 3, 4, 5, 6, 7. I can go this way, down the middle. That's 1, 2, 3, 4, 5, 6, 7, 8. So that's the one I'm going to pick. Also, because that's the one that has a triple bond. You probably, if you have the choice, make sure your double and triple bonds are in the parent chain. So that's one I'm going to pick, the middle one that has the most carbons. So 8 carbons is oct. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so that's oct. I'm right here, oct. Are there any double or triple bonds? Right over here, triple bond. So it's going to be an octine of some kind. So now I just need to figure out what carbon it's on. I'm going to number from right to left because that's closest to the triple bond. You always want to give preference to the bond. So 1, 2, 3, 4, 5, 6, 7, 8. So the triple bond starts on the second carbon, so it's oct2-ine. And then I have this guy right here, this attachment. Now this attachment has 1, 2, so it's got 2 carbons in it. So it's going to be an ethyl. Eth because it has 2, the YL and the YL ending because it's an attachment. And it's attaching at the fourth carbon right over there. So 4-ethyl oct2-ine. It's looked complicated and it sort of is, but this is about as difficult as a problem like this is going to be. So let's go ahead and jump to number 8. In my opinion, these are easier. So number 8, you have to draw the structure. So the first one is butane. So that's easy. How many carbons? 4. But is 4. So 1, 2, 3, 4. Any double or triple bonds? No. So you got to do is draw the hydrogens. And then you're done. Boom, 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 boom. That's it. But for 4, ane for no double or triple bonds. Done. Number 9. Hex 3ene. Okay, hex tells me there's 6 carbons. So let's draw 6 carbons. And then I have a double bond on the 3rd carbon. You can count from whichever side. You're making the structure. So you want the carbon, so the double bond to start on the 3rd carbon. So I'm going to say, you know, that's 1, that's 2, that's 3. That's my 3rd carbon right there. That's where my triple bond's going to go. I'm actually going to give it a different color. That's where my triple bond goes. Here we go. Just to make it different. So there we go. Hex 3ene. The only thing left to do is fill in all of the missing hydrogens. So carbons 3 and 4 don't get any hydrogens because they already have 4 bonds. They don't need any extra bonds. And that's it, hex 3ene. Number 10. 10 is 2-methylpentane. So it's 2-methylpentane. All right. So pentane, pent is 5 carbons. So 1, 2, 3, 4, 5. Ane, no double or triple bonds. And then I have a methyl group on the 2nd carbon. So my 2nd carbon, I can either go from like this side or the other side. Doesn't matter. I'm gonna, in this case, just for fun, number them from right to left because I can. So my attachment, my methyl group, this one right here, is gonna be on the 2nd carbon. So there it is. That's it. So now I just need to do my hydrogens and I'm done. Yep, that's annoying, I know. All right, there we go. That's number 10. Number 11. 11 is 3-ethylheptane. There we go. That's decent handwriting, I'm sure. So hept is 7 carbons. 1, 2, 3, 4, 5, 6, 7. And there are no triple or double bonds, it's all single bonds, so that's that. And I have an ethyl group of the 3rd carbon. This time I'm going to number it from left to right, because I'm the one making the structure. I can number it from whatever side I want. Privileges of making the structure. So the ethyl group, this right here, is on a 3rd carbon. So off the 3rd carbon, I'm going to have 2 carbon substituent. F means 2. So here's my 2 carbon substituent. So all that's left is to get my awesome hydrogens. My awesome hydrogens. I love drawing hydrogens. So good. So good. Da, da, da. You can sing if you're going insane drawing all the hydrogens. I do that in my head. There's a whole orchestra playing. Boom, boom, boom. All right, so that was 11. I'm actually going to erase everything here so I can do 12, 13, and 14. So here we go. So number 12. So 12 is 2,3-dimethyl, and we talked about dimethyl in that last problem. I don't know, a little whiles back. I think it was number, what number was it? 6. Yeah. So here you're going to be drawing that. So let's see here. So first of all, the butane. Cool. But is 4. So let's do 1, 2, 3, 4. And it's only single bonds. And then I'm telling you, on the 2nd and the 3rd carbon, I want methyl groups. I want 2 methyl groups. Di means 2, so I want 2 methyl groups. 2 methyl groups. 1 on the second, 1 on the third. So let's number this. Okay, I'm going to number it from this side. 1, 2, 3, 4. So on the second carbon, I want a methyl group, and on the third carbon, I want a methyl group. That's it. Now you just fill in your hydrogens. And do it for every other one. La 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 la. And you're done. 2,3-dimethylbutane. Wasn't that simple? Yes, it was. If you thought that was hard, you're wrong. All right, number 13 is 2-methyl-propyne. All right. All right. Okay, cool. So let's start with a parent chain, prop. That's 3 carbons. 1, 2, 3. And I want the triple bond. Now, I did not specify the number, which means it automatically goes on the first one. So first one on the left, is the first one this one? Or is the first one this one? It doesn't matter. It really doesn't. So I'm going to say the first one's the one on the right for whatever reason. There's my triple bond. And then, I'm going to do a methyl group of the second carbon. The second carbon is going to be the one in the middle. There you go. I got my carbon, or my methyl group. So now you just need to do your hydrogens. And you're done. That's it. You're done. Completely done. And did I just break something? 1, 2, 3. Ooh, I did. I didn't think about that. Prop. Yeah, this is... I actually made a mistake. That's for the next practice set. But I guess I'm jumping ahead. Right here, this can't happen. This structure can't exist. That carbon has 5 bonds. So yeah, you can't even draw that if you really wanted to. So let's fix that here. This should not even be a propene. This should be a, it should not be a propyne. This should be a propene instead. If you caught that, great job. Now, if it's a propene, that means there's only 2 bonds, and that works. Boom. Mr. B catching my own mistakes. On the fly. There you go. See? Done. Number 14. And if you caught that mistake, that means you're doing pretty good. 14 is 3,3-dimethyl. Here's that dimethyl thing again. Hex 2-ene. All right, let's start with the parent. The parent has 6 carbons. It's hex 1, 2, 3, 4, 5, 6. And there's a double bond on the second carbon. I'm going to go ahead and number it from left to right. So, that's going to be 1, 2. So I have a double bond right here on the starting on the second carbon. So there's my double bond. And then on a third, which is this one right here, third carbon, I have a pair of methyl groups. 1 here, 1 here. That's it. You're done. So all you need to do is just put your hydrogens here, and you are actually finished. And that actually concludes our problem set once I'm done putting all the hydrogens. So if you have any questions, email me in class, email me or ask me questions in class. That is so much better. Just ask me questions in class when I'm going over this. It's so much nicer to actually answer them when I'm teaching the concept than you guys later on telling me that, oh, I don't know what happened. I just wasn't paying attention. I just totally disrespected your time. Blah. All right. That's it. Thank you very much.